For today, the lesson is a plan for problem solving. This is not going to be your usual, I give you some examples and then you do some practice problems. All these word problems are different. They cover different things. It's all basic math that you should have had in 6th, 7th, 8th grade. So there's nothing new math-wise. But you must read the problem, write something down that will help you to solve the problem, whether it be an equation, a proportion, a chart, just information, a list, whatever. But you have to try something. It's kind of like asking for directions. If somebody gives you directions to go somewhere, you should either listen well and remember them or write them down so you can use them. But if you stare blankly at them and don't do anything with the information they give you, you're going to stand on the side of the road for a really long time. So blank paper is not an option. You have to try something with each of these problems. Tara read 20 science fiction and mystery novels. She read 3 more science fiction novels than mystery novels. How many novels of each type did she read? So we'll go through each piece of this. Don't try to think of an answer to a problem by looking at the entire problem as a whole. Just look at each piece of it. Tara read 20 science fiction and mystery novels. So that means when I add the number of books she read in science fiction and mystery novels, I should get what? 20. She read 20 science fiction and mystery novels. So those 2 types of books added together should give me 20. What if I used S for science fiction and M for mystery? S plus M equals 20. So we don't know what that is. What if I guess? What if I just want to take a guess and see what it is? And we'll put M for mystery and S for science fiction. What if she read 3 mystery novels? How many science fiction did she read? 17. Now, which did she read more of? She read more science fiction. So I have more science fiction there, but how many more did she read than mystery? According to the problem, she read 3 more. What's the difference between 17 and 3? 14. Is this the right answer? No, it's not. So that doesn't work. What if I chose 15 science fiction? If she read 15 science fiction, then how many mystery novels did she read? She read 5. Does that add up to 20? Now, what's the difference between 15 and 5? 15 and 5? 10. The difference is 10. That's not 3, so that's not going to work out. I'll choose another one. What about 10? If she read 10 science fiction, how many would she have to read in mystery to get 20? Is 10 3 more than 10? No. Okay, what about 11? Or no, let's choose 9. If she read 9 science fiction, then how many mystery did she read? 11. Is 9 3 more than 11? No, actually it's 2 less. Doesn't she have to have more science fiction than mystery? Yeah, so should we be using any numbers here that are less than this? No, so let's try another one. Let's try 11 here. If she read 11 science fiction novels, how many mysteries would she have to read to get 20? 9. Is 11 3 more than 9? No, it's how much more? It's 2 more. That's right. What if I chose 12? And I'll make a new list here. What if I chose 12? How many would she have to read to get to 20? 8, yes. 8 and 12 is 20. Now look what happened here. How much higher is 12 than 8? 4. How much higher is 11 than 9 up here? 2. So the difference we're looking for is in between there. Have you ever picked up a book and quit reading it halfway through? So is it possible to read a half a book? Yeah. So if it's not 12 for science fiction and it's not 11, what's in between 12 and 11? What's in between those two? 11.5, yeah. What if I had 11.5 science fiction novels read? What would I have to add to 11, or what would I have to add to 11.5 to get 20? What's 11.5 plus 9.5? 21. So what do I add to 11.5 to get 20? 8.5. Is 11.5 3 more than 8.5? What's the difference between 11.5 and 8.5? 3. Isn't that what we're looking for? Yeah, so that's it. She read 11.5 science fiction and 8.5 mysteries. And nowhere in here did I use an equation. I just guessed and checked until I came up with the right answer. Gas costs $3.52 per gallon. And that's tax included, so you don't have to calculate tax. John paid $63.24 for gas. How many gallons of gas did he buy? If he paid $63.24 to fill up his tank, and gas is $3.52 per gallon, how many gallons did he get? Let's start with this problem by thinking, I bought 1 gallon of gas. How much did I pay? $3.52. What if I bought 2 gallons? How much did I pay? $7.04. What if I bought 5 gallons? 5 gallons. $5 gallons of gas. What did I pay? Can't hear you. $17.60. Okay, so how am I doing this? When I pick a number of gallons, what am I doing to figure out how much I paid?
You're adding 1 gallon.
He had his hand up. Yeah.
You're adding more gallons each time to see when you get that number.
You're adding more gallons. So that's what I did from here to here. How did I go from here to there, though? Because it's not 3 that's the next one. How did I get 1756 from 5 gallons?
3.52 times 5.
3.52 times 5. That's right. What's the opposite of multiplication? Division. So this is the total that I'm paying in each case. What's the total that was paid in the problem? $63.24, right. So if the opposite of multiplication is division, can I not divide that total by the price per gallon and come up with how many gallons I got? So if I did 63.24 divided by 352, I would come out with an answer of 17.9659 and so on. If you put that down, I would take it. If you put 18 gallons and round it up, I'll take that. Don't come up yet. I was not done yet. If you put 17.9659, I'll take that. If you put 17.9, that's fine, because I did not tell you how to express your answer. So if you're in the ballpark like this, don't come up yet. I'm not finished. If your answer is in the ballpark like this, then I'll count it. Only in cases where you're told specifically round to the next gallon or to the nearest tenth would it make a difference. In this problem, a coin-operated telephone at a mall requires 60 cents for a local call. It takes quarters, dimes, and nickels and it gives no change at all. How many combinations of coins could be used to make a local call? So look at the problem. Whatever you put in, it must add up to be what? It's got to add up to be 60 total. And what can you put in? Quarters, dimes, and nickels. So a quarter is 25, a dime is 10, and a nickel is 5.
So do you want it to add up to exactly 60?
Yeah. Must add up to 60. So what? Somebody tell me a combination of coins that I could put in that would give me 60. Kinsler. 2 quarters and a dime. That's 50 plus 10 is 60. That's right. That would work. Somebody else give me a combination. Yes.
A quarter, a nickel, and 3 dimes.
All right, so I would have 25 and 5, which is 30, plus 3 dimes is 30. That's 60. That would work. Hanshaw. 6 dimes, right. What else would work? Yes, up here.
12 nickels?
Yeah, you could put 12 nickels in there. Anything else?
2 25s and 2 nickels.
Yeah, you could do 2 25s and 2 nickels. That would give me 60. So you see that you can come up with all kinds of combinations. It says how many combinations of coins could be used to make a local call. So what you would do is keep going through these combinations until you can't find any more, and then add up how many combinations you have. We have 1, 2, 3, 4, 4, and then 5 so far. So you would keep going to see how many combinations you could get.